Stars seem simple. Balls of burning gas, nuclear furnaces, predictable. But some stars in our universe are so extreme, so violent and so bizarre that they challenge everything physics tells us should be possible. These are 5 stars that break the rules. In the Large Magellanic Cloud, 160,000 light-years away, sits the most massive star ever discovered. J0437-4715. It contains the mass of 315 suns compressed into a single star. It is 8.2 million times more luminous than our Sun. So bright that if it replaced our Sun, Earth would receive enough radiation to strip our atmosphere in weeks. But J0437-4715 should not exist. Physics has a limit called the Eddington limit. Beyond a certain mass, the radiation pressure a star produces becomes so powerful it pushes its own outer layers away, preventing further growth. Theoretical models suggest stars cannot exceed approximately 150 solar masses. J0437-4715 is 315 solar masses, more than twice the theoretical maximum. Scientists believe it formed through stellar mergers. Multiple massive stars colliding and merging in the dense core of a star cluster. A process so violent and so rare that J0437-4715 may be unique in the observable universe. It will live for only 3 million years. Our Sun has been burning for 4.6 billion. J0437-4715 burns so bright it consumes itself in a cosmic eye blink. When it dies, it will produce the most powerful supernova in this region of the universe. The explosion will be visible from Earth with the naked eye, despite being 160,000 light-years away. On December 27, 2004, Earth was hit by the most powerful burst of energy ever recorded from outside our solar system. The source was SGR 1806-20, a magnetar, a type of neutron star with a magnetic field a quadrillion times stronger than Earth's. The strongest magnetic fields known to exist in the universe. In 0.1 seconds, this magnetar released more energy than our Sun will produce in 250,000 years. The burst was so powerful, it physically compressed Earth's ionosphere from 50,000 light-years away. It disrupted radio communications globally. Scientists' instruments went completely off scale. To understand the magnetic field strength of a magnetar, consider this. If a magnetar were placed halfway between Earth and the Moon, its magnetic field would be strong enough to pull the iron from your blood from that distance, not damage you. Pull the iron atoms directly out of your body. SGR 1806-2. O is 50,000 light-years away. There are magnetars closer. The nearest confirmed magnetar is approximately 1,000 light-years away. A starquake from that distance would be catastrophic. Ozone layer stripped, radiation bathing Earth for years. We cannot predict when a magnetar will fire. We monitor them constantly. We understand almost nothing about what triggers them. Eta Carinae is a ticking bomb, 7,500 light-years from Earth. It is not one star, it is 2. A binary system containing stars of approximately 90 and 30 solar masses orbiting each other every 5.5 years. The larger star is one of the most massive and luminous stars in the Milky Way. In 1843, Eta Carinae underwent what astronomers call a great eruption. For 2 years, it became the second brightest star in the night sky, visible in daylight. It ejected 10 to 40 solar masses of material in a massive explosion that was not quite a supernova. Something in between, a hypernova eruption. Nobody predicted it. Nobody understood it. Even today, the mechanism that caused the 1843 eruption is not fully understood. The material ejected in 1843 is still expanding outward, forming the homunculus nebula visible around Eta Carinae today. Two lobes of dense gas moving at 600 kilometers per second outward from the star. Eta Carinae is expected to go supernova, possibly within our lifetimes, possibly in 10,000 years. When it does, the gamma ray burst it produces could be dangerous to Earth if the poles of the explosion are aligned toward us. We don't know if they are. We won't know until it explodes. Pulsars are the remains of dead stars. When a massive star explodes in a supernova, its core collapses into a neutron star. A sphere of pure neutrons, approximately 20 kilometers across, containing more mass than our Sun. PSR J0437-4715 is a millisecond pulsar. It rotates 174 times per second. Every rotation produces a beam of radiation that sweeps across space like a lighthouse. We detect these pulses with such precision that this pulsar is more accurate than atomic clocks. But in 2024, the James Webb Space Telescope measured the surface temperature of this pulsar and found something impossible. It is too hot. Far hotter than it should be given its age. Neutron stars cool down over time. This one is not cooling at the expected rate. Something is generating heat inside it that our models don't account for. The leading theory involves dark matter. Particles of dark matter being captured by the pulsar's enormous gravity and annihilating inside it, generating heat. If true, this would be the first indirect detection of dark matter particles through their heating effect on a dead star. A 20-kilometer dead star rotating 174 times per second may be telling us something fundamental about the invisible matter that makes up 27% of the universe. In the early universe before the first galaxies formed, there may have existed objects that push stellar physics to its absolute limit. Quasi-stars, theoretical objects so massive they make R136A1 look small. Stars containing millions of solar masses. Objects so large that instead of the normal nuclear fusion that powers stars, their energy came from a black hole forming at their core and consuming the star from the inside. A star powered by a black hole eating it alive. The black hole forms at the center, begins consuming the stellar material. The energy released by this consumption heats the surrounding gas, creating outward pressure that temporarily supports the enormous mass above it. The star and the black hole exist in a temporary balance, the black hole eating the star's energy fighting the collapse, a death match between a stellar envelope and the black hole consuming it from within. Quasi-stars would have been thousands of times larger than any star that exists today. They would have lived for only a few million years before the black hole consumed everything. We have never directly observed a quasi-star. They existed too early in the universe's history. But the supermassive black holes we find at the centers of galaxies, including our own Sagittarius A, may be the remnants, the final product of quasi-stars that burned bright and fast in the universe's first billion years. The black hole at the center of our galaxy may have once been the heart of a star larger than anything that exists today. 5 stars that break the rules. R136, a 1 exists at twice the theoretical maximum mass. SGR J0806-20 already hit Earth once from 50,000 light-years away. Eta Carinae erupted once without warning and could go supernova in our lifetime. PSR J0437-4715 may be revealing dark matter through its impossible temperature. Quasi-stars powered by black holes consuming them from within may have seeded every supermassive black hole in every galaxy. The universe doesn't follow our rules. It creates what physics says shouldn't exist. and then it destroys it on timescales that make human civilization look like a single heartbeat. Follow for daily cosmic threats, because the stars are far stranger and more violent than anything we were taught.